All right, let's get started. Welcome everyone to Losant's Deeper Dive webinar series. For everyone that has joined us in the past, welcome back. For anyone new, welcome. If you're catching us on the replay, well, I guess welcome at a future time. The Deeper Dive webinar series gives us an opportunity to, like the name implies, we're going to dive deep into some technical concepts about Losant, or sometimes in this case, some of our partners. The webinar series isn't designed to provide an overview of Losant itself. If you are new to Losant, I definitely recommend staying tuned. You'll definitely learn something about Losant. But you can feel free to reach out afterwards, and we can get a more dedicated demo and overview scheduled for you at a later time. So a little bit of housekeeping. The webinar is recorded. I know a lot of our viewership comes from replays. Not everyone's available live. But one of the best reasons to join us live is for Q&A. So we do leave time at the end for Q&A with the speakers. And I want to just draw your attention in the web or the Zoom webinar tool here. There's a button called Q&A. Just go ahead and click that. At any time during our presentation, feel free to ask a question in there. And then what I'm going to do at the very end is we're going to come back and answer as many of those as we can. So don't hesitate to drop your questions in there. So speaking today, first of all, it is me. I'm Brandon Canaday. I'm the Chief Product Officer at Losant. I'm going to kick things off, and then Alan Clark is joining us, the CEO of one of our partners, Telchemy, and he's going to be presenting a little bit about their edge compute offering called Embiot. After he's done, I'm going to come back and I'm going to kind of wrap up talking a little bit about how Embiot and Losant work together from the Losant side of things. For everyone that is new to Losant, we are an enterprise IoT platform. We provide the software behind IoT product services and solutions. There is a lot of features and functionality in our platform. We're not going to get to all of it today, but we cover everything from the edge computing all the way up to the end user experiences. And today we are going to talk a little bit about the devices and data sources. So after Alan gets done, I'm going to go in and talk a little bit about how we can use the data coming from their edge compute offering, as well as the visual workflow engine. And like I said earlier, if you do want to get a full demo of everything else Losant has to offer, don't hesitate to contact us and we'll get you hooked up with a team member from our side. We have offered our platform, provided the foundation for a lot of companies across a lot of industries, both large and small, focusing heavily in the industrial equipment monitoring, smart environment, telecommunications, really exploring ways to take existing product lines and turning those into enterprise connected products. We all understand IoT is a pretty broad technology stack. It takes a village to bring an IoT product together or to life. And today really highlights one of those partners in this overall ecosystem. And for Losant, we divide our partners into these three buckets: strategic partners, where we share go-to-market strategies, a little co-sell and co-marketing; service partners who help actually develop that customer-facing product, really bring all these pieces of the stack together; and then what Telchemy is today, one of our technology partners. So Losant provides a lot of the software stack, but there's still a lot more software, a lot more hardware, connectivity that's required to pull it together from a technology perspective. So we have worked very hard to build a really robust and qualified partner ecosystem around the platform that we provide. And that's all the upfront I need to do. Let's get right into the webinar. We're going to be talking about Embiot's edge computing and edge analytics offering today. And before I pass it off to Alan, I kind of wanted to share a little bit from Losant's perspective about why Embiot kind of at all. For anyone that is familiar with our functionality, there might be a little confusion between Losant's existing embedded edge agent and our gateway edge agent, and where Embiot, another computing or edge computing offering, fits in this overall technology stack. And we met these guys quite a while ago. They showed what they had, and I really liked that it filled this technical gap, kind of this perfect slice of technology between our edge agent offerings. On the kind of far left, you've got the embedded edge agent. It doesn't require an operating system. It really has no system dependencies, but it's compiled into the firmware. It takes a lot of upfront development work to get that working. But, the trade-off is you can run that on, very small devices. It's designed to be built right into the device firmware or run on what I call embedded gateways, which are gateways that you may not have access to the underlying operating system, but they provide some application space. And then on the far right is our gateway edge agent. It requires a Linux, a lot of system dependencies. It requires Docker, kind of designed for those medium and large gateways, requires a few more system dependencies. And where Embiot fits from a technical perspective is right in the middle. So when we think about industries that might be attracted to this offering, I really go to that industrial equipment monitor. We see a lot of our customers adopting gateway retrofits. They want to include an off-the-shelf gateway, sometimes integrate it directly in the equipment or the chassis, connected to the controller itself. And the embedded edge agent, that's a lot of upfront work. You may not need that level of custom firmware development. The gateway edge agent leads to kind of these more expensive gateways where the unit economics may not work out. So for those companies that are, thinking about, small and, medium gateways, still, using an operating system, something like an Embiot can really reduce that cost, reduce the unit cost to get some edge computing out there and get that data up into the Losant platform, where then you develop a customer-facing application. So with that, I just want to spend, just 2 minutes there for, the returning users that are familiar with Losant to understand where Embiot fits within kind of our product portfolio. So now I want to hand it off to Alan, and he's going to give us a much deeper dive into Embiot, how it works, and how to start sending that data up to the Losant platform. So with that, I'm going to hand it off to Alan.
So great, thank you, Brandon. So let me just share my screen. And so can we see my screen?
Yes, I can.
Good. So, so my name is Alan Clark. I'm the CEO of Telchemy, and so I'm going to talk about Embiot, which is the name comes from embedded and IoT, obviously. So Telchemy was founded in 1999, so we've been around for quite a while. So the picture that was shown of me on the earlier slide is very dated. I look a lot older than that. We have a focus on embedded analytics and edge analytics. Our initial products were focused on voice over IP and also video streaming and video conferencing. And we have an install base of over 500 million units of that technology. So we have a long history in the embedded analytics space, but not so much in industrial IoT, more in voice over IP. And so Embiot is a new product we introduced just about the time COVID started, which is focused on applying what we've learned from our work in embedded analytics and edge analytics to the IoT space. So the approach is to use a low code approach. In other words, something that you write code for, but it's very simple. A very small amount of simple code, easy to use, feature rich, a number of well-defined methods of getting data in and out, and a rule-based programming language. And I'll show you all of this shortly. It uses a compute flow or stream processing architecture internally. So because this is a very good way to handle asynchronous data streams. If you're connected to a lot of different sensors, then data is going to arrive at different times and make its own way through. You may have to deal with missing data or data that's delayed. It has a rich set of functionality. So in each of the nodes in its stream processing architecture is a function that could be simple or complex. We've built it for multiple platforms, so Intel or ARM, and then Linux, Windows, and Mac OS. And it's small footprint. And so what we mean by small footprint is around 300 kbytes, including all the code. It also includes a runtime compiler. So you basically just write code, run it, and it compiles and executes. And it has a low fixed memory usage. So it doesn't sort of allocate memory on the fly while it's running. It decides how much it needs, allocates it, and then starts. So high level looks like this. So you have, as I mentioned, you have a runtime compiler that takes your program file and builds this. you have a number of methods of getting data in. So you can just send data to it through a socket, or it can do polling. It can do MQTT and Modbus polling, and then it automatically detects the protocol. So it knows about JSON and XML and name equals value. It matches the metrics that you've defined, and then queues the input values, and then computes them. So data kind of flows through this stream processing model, and then on the output side, at intervals, it'll take the output values and generate a report and send it. And it can send reports to multiple different places. And it does include an MQTT implementation as part of all of this, which we'll show you. So the advantage with using the runtime compiler model is that it very much shortens the whole time it takes to get code built and tested. So you can have something running, you can just stop it, edit the code, and start it up again in a matter of a few seconds. So it's very good for experimentation, or for, once you've got it working, then just leave it running. So for a small to medium size program file, it'll compile in a second or so, and it compiles the config or program file into an executable compute flow, pre-allocates memory and queue sizes and buffer sizes based on what it thinks you're going to need, and then when it runs, it actually saves some statistics on memory usage and buffer usage. So next time you run it, it'll actually size the buffers based on what it knew it needed from last time, as opposed to just its default values. On the input side, it's really designed to try and make life as easy as possible. So you can just send it data through a UDP or TCP socket using some arbitrary text protocol, and you can use name equals value, name colon value, JSON, XML, URL encoded data, and it'll automatically figure out what format it was, and then extract the metrics and try and match them with the metrics you've defined. It supports HTTP or HTTPS put and post, and again, you've got a variety of ways of the data can be encoded. It accepts an MQTT publish, which could be an unsolicited publish. In other words, something could just send it a publish, or it could result from a subscription, and it is capable of subscribing if you want it to. So if you declare a device as an MQTT device and provide it with a topic string, then it'll subscribe to that device, to that topic, and as a result should get MQTT published messages back automatically. And then it can do a more explicit polling via Modbus, via TCP gateway, and also it can do HTTP or HTTPS GET polling too, and we'll show you that. And then we're in the process of adding CoAP and also direct IO, by which I mean the ability to directly access things that are located in memory or IO space on the hardware. Now, the compute flow part of it is essentially it's a series of interconnected nodes, and each node is going to do something. It can be a very simple function, like add two things together. It can be a fast Fourier transform, an autocorrelation function, a neuron, fuzzy logic. Can be all sorts of different things. And so basically data is just going to flow through an interconnected series of nodes, having things done to it, and then eventually you get output, which is formed as part of a report. And then the nodes also keep track of things. So they don't just hold the value, they also keep track of the last value, the last time that node is updated. If there are any math errors, it counts those for that node. If there are any timeouts, in other words, data didn't arrive on time, then it can count that too. And so that way, that information is available for each node. So if you're trying to sort of debug what's going on with a series of operations like that, it actually can give you quite detailed information from internally from within this network of nodes. And the functions are somewhat designed around use cases. So for example, with an FFT, FFTs would typically produce a whole bunch of output coefficients. And what you really want to know are the things like the harmonics and spectral peaks and those kind of things. And so the FFT function in here computes the FFT, but it also calculates finds the harmonics and spectral peaks. And those are just available from the output of the node. So the output of the node can give you, the full set of coefficients, or it can give you the first or second or third harmonic. And then if you have multiple logically separate flows of data going through the same system, then you can have logically separate groups of nodes. So they don't have to interact with each other if they don't need to. And then on the output side, again, we've tried to make things fairly easy to do. So there's reports are generated either at fixed intervals, or they can also be generated when an alert condition occurs. And the report outputs can be in MQTT. So you can do, so it will accept a subscribe but send a publish, or it can just send a publish. It can do HTTPS, HTTP, HTTPS post or put, like a REST API. You can create a custom text template, and it'll substitute values in the template with metric values. And then it also allows you to use a web browser just to get the value which can be in JSON, XML, or HTML table. So you can just use a browser to do that. And you can generate as many reports as you want to different destinations. So these could all be different places. So the sort of high level then is it's a small footprint embedded IoT analytics agent. It's low code, and I'll show you some examples in a minute. Easy to program, allows rapid development. It's programmable, customizable in the field. All you need is a text editor, and you can change what it's doing. It's got advanced functionality, so you can implement things like neural nets in it if you want to. Small footprint, multi-platform, incorporates a range of input and output methods, and also supports TLS security. So the demo I'm going to show you, so I'll walk through what the code looks like, and also do a demo of this. So the demo setup is just Embiot running on a Raspberry Pi 4. The code size on this platform is 229 kbytes, and so it's going to interact with some Modbus sensors using Modbus TCP, and it's also going to get information from an API, a web service API on the internet, openweathermap.org. So it'll do a combination of getting data from some Modbus temperature sensors and getting data from the weather API. So let's take a look and see. So the installation of Embiot is fairly straightforward. It's a simple single binary. We can build it with and without TLS support. If it has TLS support, then it does use OpenSSL, so it would need that to be installed on the platform it's on. And obviously, you'd have to have certificates available if it needed them. So what you require is the Embiot executable, an identity file, what they call the embiot.idf. So this holds things like your organization ID, a license key, and some other properties. And then there's the something.cfg is the configuration or program file. And so that's actually what gets executed. And so to execute it, we just do embiot -c and then the name of the config file. So what an Embiot program looks like. So there's a number of options. So we'll see some specific examples in a moment. So there's a number of options you can set. So you can tell it to run in higher speed mode or lower power mode, and so you can trade off throughput versus CPU usage. It's got a lot of debug options available. You can define the listening ports that you want it to open, ready to accept things, that kind of thing. You define report blocks, gateways and brokers, device classes and devices, metrics and rules. So let's go through each of those. So for a gateway, so this is actually from the demo I'm going to do. So so for a gateway, so this is a Modbus TCP gateway. So we give it a name. In this case, we're giving it an IP address. It could be a host name, but an IP address and a port. And then we're saying that the protocol is Modbus. And then we can also define the MQTT broker. So this is Losant. So the broker name is Losant. The host name is broker.losant.com, port 1883. And You can set various MQTT settings like QoS level, and then you have these are kind of mangled a bit, but these are the client ID, username, and password that Losant need, or at least representations of those. And then for devices, we have a device class structure, because the assumption is you may have quite a few of something. And so if you do, then you can define a device class for it. So in this case, we have two temperature sensors, and so we've defined these as being of class Modbus dev. So their protocol is Modbus. We're going to poll them every 25 seconds, and they have Modbus. I'm not a big fan of Modbus. I know it's hugely widely used. So in Modbus, you have numerical registers, and so in this case, the temperature is 30,002 and humidity is 30,003. And then you can define what type these are. These are integers, the byte ordering, byte and word order, and these are inputs. Now, to make it easier to work with in the rest of the code, it's easier to give them names. And so what we've done is we've said the register named temperature is corresponds to Modbus address 30,002, and the rest of it applies. So now we can refer to these as temperature and humidity. And then to make life more convenient, I can also define my own variables as part of this. So even though temp C, temp off C, and humidity off are not part of that Modbus sensor, by creating those as user-defined variables, it means that I'm automatically going to create those in the same kind of namespace. So it just makes it easier for me to work with things later on. And then I can define my devices. And so I can define as many of these Modbus dev devices as I want to. And I've just called them sensor 1 and sensor 2, in this case, just 2 of them. So they're of type Modbus dev. And I can get to them through the Modbus gateway we defined on the previous page, and they're at Modbus address 1. And so sensor 1 is at Modbus address 1, and sensor 2 is at Modbus address 2. And that's basically all I need to do. And so if I had 10 of them, I'd just carry on doing the same thing. And then this automatically creates a hierarchically named metric. So the fact that I defined sensor 1 as sensor 1 and of type Modbus is going to automatically create something called sensor 1/temperature, which I defined up here, sensor 1/humidity, and also sensor 1/temp C, temp off C, and humidity off. And the same thing for sensor 2. So I can use those in my later rules if I want to sort of manipulate those values. Now, if there are things that I want to do which are outside of the metrics that will be created by doing that, then I can just define them. So I can say, metrics equipment room humidity is an integer, or equipment room temp aff is a float. So I can just define those. And then I define rules, and my rules are exactly what you'd expect. It's the humidity value that comes from these sensors is actually scaled by 10. So you have to divide the value by 10 to get the real humidity. So I can say the equipment room humidity is sensor 1/humidity divided by 10. And I can do compound functions, and I've got lots of math functions I can include in here, but it's very sort of algebraic language. And so here I'm converting sensor 1 temp C, scaling it by 10, converting it to degrees Fahrenheit, and then rounding it, and that becomes equipment room temp aff. And then reports look like this. So these are again, it's another block. So you have a report name, report type, MQTT. We want to send it through to the Losant broker, which we defined earlier. If I say report CLI true, then it'll also output the report to the command line so I can see what's going on if I want to. And then being MQTT, we need to give it a topic string. So that's the report topic. We want to encode the data in JSON, send it every 10 seconds. We want it to work. So we're saying we'll enable it. So if you want to just run it in test mode, you could do report enable false and report CLI true, and then you just see it on the command line. And then you can define a numerical or text value for unavailable. So in other words, if you have metrics that are not available, it would substitute whatever you put there for that value. And then you put the list of metrics that you want in there. And you can also put wildcards in here. So in this case, equipment room, I have 2 different equipment room values and 2 different server room values. So I can just put a wildcard in there and it'll put both in. So let me switch across now to look at something. Right, so this is Embiot running. So it's basically reading the values from the 2 sensors located in this building, and also it's getting the value from the weather API, just the last one. So it's 82 degrees here right now, and then it's sending those through to Losant, through MQTT, and we're getting PubAx back. Now I might want to see a bit more detail. So if I do, so this is the actual program that's running. And so because I said debug mode MQTT, it's showing me that very summary level. I sent a publish, I got an ACK, but we can do detailed. We can do polling. So I can save this. Exit. And then, so all I need to do is just to restart this. And you saw it started almost instantly. So now it's running the revised version of itself with, so it's connecting back to Losant, and now with MQT detailed, it's actually showing us the detail of the messages that are being sent and received. And so you can see all the gory details. I also turned on polling debug as well. So we should see in a minute some the polling information. So this was the 2 MQ polling the 2. Scroll back down to that. So this is it polling the 2 Modbus temperature sensors, and so these are the values coming back. So you can see the request going out and the response coming back, and so that value will, in a minute, will start to appear in the reports that are being sent. So it does a Modbus decode, and then this is this big chunk of text here is the request it's making to the weather API service. So it's sending a get requesting the weather for this location, and so this is the response coming back. So you have the coordinates, weather, and so on. It's in Alpharetta, Georgia. And so you can see all the details that are coming back. And so what I'm doing is I'm pulling some values out of there and then incorporating them into the data that's being sent. So that value is actually going into the this unique ID 6. Now, various other nice things you can do as part of this. So something we're doing here is to use aliases. So what I can do here, because I've got what we wanted for this demo, we wanted to have the reports that came out that showed the same thing. So basically, they all say temp F, temp C, humidity, unique ID, even though they represent different sensors. And so in order to make that easier, but our metrics actually have very specific names. So equipment room temp F. So what I did was to create aliases for all of these, and then when I put that metric into the report, like up here, so when I put that metric into the report, then it's actually like equipment room star here. So what it's doing, it's inserting equipment room temp F, temp C, and humidity in there, but it's using the aliases to put in the report. So that way it lets me give them all very generic names, even though when I'm working with them down here, they've got specific names. So so that's that. And then so let me just exit from this. And then something else we can see here, just a practical point, is so just a practical point. So we have quite a lot of logging going on. So we have this is the program it's running out of, the folder it's running out of. So you have the Embiot executable with 228K. There's the configuration file we're running, which is 3.7K. And then we have various log files that are going to indicate if anything's going wrong. And so we also have this PRF file. So the PRF file is provides performance statistics. So that can be useful to figure out if things are not working the way they ought to. So it has all sorts of things like processing delays and queue writes and messages received and messages sent. So a lot more detail than you probably need. And if I look at the Embiot IDF file, so this is our identity file. So we have a license key, the location of the license server, and you can also do remote configuration. So there is a portal called portal.embiot.io, and so that's where the license keys come from. But also it has a configuration section on there, and so you can put a configuration in there, and then tell Embiot to automatically check back. So it'll check back there whatever intervals you tell it to, and see if there's an updated config file, later version of config file for the one it's running. And if there is, then it'll download it, exit, and then if it's running as a service, then it would automatically restart using the new config file. And then you have various fields down here, the vendor ID, and then some fairly free usage things like device type, device version, device ID, location, and so on. And those you can use to identify this. You can also use these for matching configurations. So if I had a configuration file on the server, I might use it. I might say this is for project RPi 3, Alpharetta, Raspberry Pi, and so it'll check something that matches that, and then download it and use it. So so those are the key elements. So I'm going to switch across to Brandon now, so he can show you the other side of it.
All right, thanks, Alan. Let me share my screen. So while I'm bringing up my screen, what we just covered was the configuration required to read some data from some Modbus devices and then report that over MQTT to a custom topic up in Losant. Of course, that concept will apply to basically any broker you're using. But what I want to show now is a little bit of what happens when we get into the Losant side of things. What architecture we really displayed here is really interesting. Not one we've ever covered on a deeper dive webinar before, which is, first of all, reporting to custom topics. Normally, most of our webinars are reporting to those kind of special device topics like state, where the platform just kind of directly understands the data. This is demonstrating a edge computing or a gateway that's reporting to other kind of just completely custom topics. I'm not going to cover the data visualization side. We've covered that so many times. If you do want to know, like, well, how do I put my data on a dashboard? We've got a wonderful walkthrough that does pull data from a weather API and covers how to put that on a dashboard. So that I'm not going to cover today. But the first thing I want to talk about is just kind of showing that data once it hits the platform. And right in here, we've got the application communication log. It's on the overview page. This is probably one of the most important things to pay attention to as a new Losant user. And we can see right here that we're getting that raw message. And this is based on one of the reports that Alan just showed in the configuration. Like you showed with those aliases, we're getting data for multiple devices, all with the same field names: temp-F, temp-C, humidity. What's changing is the unique ID. And this is a really common edge architecture where you may have a gateway reading data from multiple identical or very similar devices. So in that incoming payload, you have to include something that can uniquely identify that device. And that's really what I wanted to show here in kind of this portion of the deeper dive. So if we do look at the device hierarchy here, we're making use of the gateway and peripheral concept within Losant. We've got great documentation on that. That's what I'm showing here is our documentation page. If we switch back to the portal, we'll see that is represented here as the Raspberry Pi gateway. You can also run an Embiot on a MacBook and other things that Alan said, but what we have connected and sending data right now is that Raspberry Pi. That's the gateway. And then we've got these three peripherals, the two Modbus devices. They're identical devices, but they're collecting temperature and humidity data for two different rooms. And then we've got the one representing the weather. So what I've added here is the tag that corresponds to the identifier sent through the payload. And great pro tip for Losant users, if you've never noticed this little customized column button, definitely explore that. It allows you to add additional columns to your device table. And what I've done is added the unique ID tag so we can kind of see the 4, 5, 6 that map the IDs coming through the platform. If we go ahead and open one of these up, we'll just see down at the bottom, we do have that tag. And then if we scroll back and look at the attributes, we've got the humidity, temp C, temp F, and then we can kind of see data flowing in here. One of the most important things to remember when using custom topics is Losant takes a security model of kind of opt-in. You have to grant access to devices when it comes to custom topics. You know, devices, connections into your application to our MQG broker just can't arbitrarily read and publish data. That's you might accidentally expose information you don't want. So when you are creating an access key, what you'll need to do when using custom topics is come down here and specify what you'd like. So in this case, I only want to allow the following topics, and this is that Telchemy topic here. We do support wildcards. So pay attention to that. If you've got a device and you're attempting to publish on custom topics and you don't have the access key configured correctly, what you'll see in that application communication log is an error. It'll say, you know, device attempted to publish on a topic it wasn't allowed to, and it'll disconnect the device. So if you are seeing that, that probably means the access key doesn't match the topic you're trying to post to. So if we switch back here, we can see we've got raw JSON data coming into the platform. You know, Losant doesn't really know this is JSON data. It's not inspecting those MQTT payloads. So that's where we're going to switch to a cloud workflow in order to decode and then ultimately report the data on the correct device. And this is really where that peripheral gateway association comes in handy, and also the unique identifier specified in the payload. So let's check out the data handler workflow. This is kind of the meat of this whole architecture. Also kind of a good place to talk about, you know, one of the main differences between how you program Embiot versus Losant. You know, what Alan showed is a very declarative approach to edge computing. It's almost like a programming language. And Losant takes a very like a flow-based approach. And that declarative approach can be simpler in some cases, like in this case where I've got Modbus devices, I just need to get the data, read them, and report them. He did show some really nice edge analytics there, very light. I think just barely scratched the surface of what Embiot can do with streaming analytics. But you know, that's a lot easier to version control versus our workflow can be easier to do those very simple tasks. So it's a very different way to design your edge logic, but it can be beneficial in certain circumstances. In this case, though, I'm looking at a cloud workflow. So the very first thing that's happening is we're triggering whenever data is received on that topic. So this is one workflow that will support data for any number of fielded devices. It's a very important concept in this architecture. You don't want to field 10,000 of these edge devices and have to build 10,000 workflows. We really want to design a data architecture and a hierarchy where I can build one workflow, all the data gets funneled to it, and then I can make decisions in that one place. After that, as I mentioned, Losant itself doesn't know when you're using custom topics. It doesn't make any assumptions on the data format that you're reporting. In this case, we are reporting as JSON, but you can report really any arbitrary bits and bytes in an MQTT payload. The first thing we have to do is decode that data. We have a lot of decoding nodes, encoding and decoding nodes. In this case, it's JSON, so we're going to use the JSON decode node. This is a nice little trick. The raw data, that raw JSON string is coming in on the data. I just decoded in place. So now when I look at my payload, I see the actual payload that was sent. It's just right in line. It just kind of replaces the raw string with the decoded string that now it's a little easier to use. And then now that kind of architecture we talked about comes into play. The first thing is a device get, and this is the really important node here. We've got the gateway ID. What we want to do is find the right device. So let's pretend again we've got 1,000 of these gateways at all kinds of sites, and they're all reporting data for basically the same type of peripherals. You know, you may be building a smart environment product and selling it to all your customers, and they all kind of have the same sensors that go along with it. You don't want to build these workflows for all of them. You just want to be able to look up the right device. So in this case, we're looking for all the devices whose gateway ID, kind of going the opposite way, a peripheral has gateway, like a parent gateway, that's equal to the device that came in. And this is kind of a little pro tip that a lot of people may not know. It's kind of a hidden feature of Losant. This relay ID property, it does represent a lot of different things in Losant, but it's usually representing kind of what generated the data. You know, if you click like a virtual button, the relay ID is like the ID of the virtual button that ultimately clicked it. In this case, the relay ID is the device ID that published to this incoming topic. So we can use this to know, well, which gateway, which MQTT client actually published this message. So that's what we are mapping right here. That relay ID is here. And then we're doing that unique ID lookup. So it's okay for devices at different sites, different peripherals of different gateways to have overlapping unique IDs because we're also scoping it to the relay ID. Another really common ID that comes in might be the IP address. I've used that in a lot of cases, especially for Modbus. I might just report, well, here's the IP address of that Modbus device on the network, and then I can tag the Losant with that same IP address. And you may have two devices on two entirely different customer networks have the same IP address. That's totally fine. This is a good way to look that up. So coming out of this is how we identify the right device, the right gateway and peripheral that ultimately reported this data. We do a quick check, you know, do I even have the device? This is a really good spot to do maybe some on-demand device creation. So if it makes sense for your application, if you receive kind of a new piece of data for a device you don't know, you could have a recipe in Losant. You could create it here and then kind of bring it back and continue the workflow. But this is really where naming those aliases that Alan talked about add a lot of power. I don't really need to know, you know, this peripheral has these attributes, this peripheral has these attributes. In this architecture, the peripherals are kind of all identical sensors. They all have a humidity, temp F, temp C. So after I found the appropriate peripheral, I can just report those data. I know it has those attributes. I know that those values are on the incoming payload. So I can just report them here. And what that results in is devices over here that do have that incoming state. So every 25 seconds or so, based on that polling interval for the Modbus devices, we're getting this device state data. So that's really what I wanted to show from the Losant side. I thought this architecture of the edge devices out in the wild, all having kind of similar peripherals. We see that a lot. A lot of gateways are reaching onto local networks, reading identical sensors, reporting up that information. So this is a really nice kind of deep dive into that architecture. So now I'm going to wrap it up, and we'll have the rest of the time for Q&A. Looks like we do have a couple of questions. The first thing I want to do is if you are a Losant user, you know, we are you know, really excited for you to leave some reviews on these platforms. And I kind of just share your experience with the world, help get our name out there. That would be very appreciated. The next thing is a save the date. So just next month, kind of late September, we've got Brian Cercio, who leads our internal solutions group, and he's going to be talking as part of the IMC fall days and about what makes IoT projects succeed. And he is probably one of the best people on our team to understand that, because he does lead the development directly hands-on for a lot of our customers as they're developing their solution. So please check that out at losant.com/events. You can register for that and catch that talk. Some additional resources that, some follow-up information you might want to check out. If you do want to see more about Losant specific edge compute functionality, as I mentioned, it does work a little different, kind of flow-based. You can find that in our documentation and go to docs.losant.com. You'll see the edge compute in the left-hand nav. We do have a nice demo of our data visualization. I didn't cover it here, but if you do want to see how that works, oftentimes the next step after recording that device state onto a device is then to go to the dashboards and start presenting that. So we've got a great data visualization demo you can check out. And also is workflow alerting. Check out this template in our library. Losant does ship a lot of pre-built functionality. Definitely explore that template library. And, we showed us bringing data in, decoding it, and storing it. But a lot of times, one of the next things you want to do besides visualizing it is also set up some alerting. I want to capture those exceptional occurrences. I want to then notify the correct personnel. Might be service support technicians, might be your end customers that something is wrong with the equipment that they purchased from you. So it's a nice little template to lay a starting implementation that you can expand on. So before we get into Q&A, these are just our general support and documentation resources, always worth exploring. That middle one there, the deeper dive series, we've done a lot of these that cover a lot of partner technology like today, but also a lot of just kind of Losant implementations. So if you're in there building out end user experiences or building solutions, certainly explore that. It's a very valuable resource when it comes to learning how to do Losant. And then, reach out to us on our forums. We're always there. A lot of our team hangs out there, kind of ready to answer questions. If you've built something cool, certainly let us know. Show us what you've built using Losant. The rest of the community would love to hear it. So let's get into the Q&A. First up, I mentioned early that the Embiot is great for small gateways. I certainly didn't define what small meant. This demo Alan used has a Raspberry Pi 4. So the question we got is, what is the minimum platform that can be used? I guess the minimum system specs. Alan, you want to tackle that one?
Yeah, sure. It's you can say the minimum system is something that requires at least a minimal Linux-like operating system with multi-thread support. But we've happily run Embiot on, for example, Raspberry Pi Zero. So in terms of actual CPU consumption, it's memory consumption, it's actually relatively small, but it does require a basic Linux that's able to support multi-threaded operations. So it's not available, for example, on an RTOS that doesn't support that.
Okay, thanks. Next question is, Alan, you showed a lot of kind of local editing of the configuration. Do you provide any like remote portal or any way to update that configuration remote? The device is kind of already in a customer's hands or something like that?
Yes, to a degree. Yeah, there is an Embiot portal, and so customers have access to that. And within that, there is a configuration section. So you can create a configuration and put it on that portal, and then the agent will automatically check back into the portal to get a configuration file for itself. And so it uses the properties that were in the IDF file. There were various location device IDs and things like that. So it uses those properties to try and match a config file. So if you started up an agent and its IDF file says, do go check in with the portal for your config file, and it doesn't have one, it'll automatically go to the portal and it'll share its those properties. So it'll say I'm project Losant or whatever, and then the portal will try and find a configuration file for that customer with the right ID that matches that property, and it'll download that config file to the agent automatically, and then so the agent would then save that and then have to be then restart, and then it would periodically check back. So if you wanted it to check back every 30 minutes or 24 hours or whatever, then it would check back and go through the same process to see if there's because the configuration files are versioned, so it'll check back to see if there's a later version of the same config file.
Okay, yeah, that makes sense. And an interesting follow-up to kind of the remote portal is, does Embiot have an API? And the reason is they're building a Losant experience and they want to enable some amount of that device configuration or device management kind of to the end user through like a Losant workflow hitting maybe an Embiot API. So I guess looks like the ultimate question is really, does Embiot offer an API where you can kind of do that management through external services?
Yeah, well, specifically for the configuration part of it, we're I wouldn't say that there's explicitly an API, but it's a fairly simple REST protocol that's used by the agent to go request things, and we're quite willing to share that. So we don't regard that as proprietary. So so it would be possible for somebody, Losant or a Losant customer, if they felt it more convenient, to implement the configuration server functionality themselves, just using the same protocol.
All right, cool. I'm going to go ahead and wrap it up here. Looks like we're basically at the top of the hour. This final slide here is really just how to learn more about Losant and Embiot and Telchemy. You can find us at losant.com or shoot us a message at hello@losant.com. You can find Embiot or Alan at telchemy.com/embiot.php. So this is where you'll want to go to find next steps. Thank you, Alan, for joining. Thank you, everyone else, for attending, and we'll see you on the next deeper dive.
Right, thank you.